it's fine. It's okay. It's okay.
Sorry, Allie.
No,
I know that probably doesn't help your nausea.
All right. Yeah.
It was the ghost.
Really? You just went flying. Did it turn off?
Are you okay?
Are we on part 3 now?
Yeah.
Wait, part
Did it
3
turn
already?
off?
We still have 6 minutes in this second part.
But it went off, so there's nothing I can do about it.
In the second part?
All right.
So we're on the third part now?
Yeah, we went over the problem. And did it restart? No, because it restarted.
So it started recording, like stopped and started.
All right, I think we're on part 3 now.
Start the timer again.
Yes.
All right,
So part 2 is gonna be really short.
On day 5 notes, let's go over the
It was
check your
short because it
understanding.
fell
Hurry
down
up
and
so
it
we can
turned
go
off.
on.
And it's a new video.
I know.
Okay.
All right, are you there with me? Okay. Very good. You have yours? I don't think I have
A
enough.
whole new
Brandon,
video.
it looks like this. And we're looking at the back of it. It's the one we were working with yesterday. Day 5. Day 5.
You have stuff on the
Yeah.
Do you know this?
All right. We're going to cover this quickly. They have some questions here, and they want to know if they are independent. You know what? We're not going to do this because we just did one on the board. So it's right-handedness and left-handedness.
Did you understand?
So Brandon, never mind.
Yeah, I'm not really sure what I was
All right.
confused about.
Do you have room on here to draw a
Yeah.
tree?
It's a good feeling.
Yeah.
Oh yay! All right. So take the notes on the back of there.
10 feet?
Yeah. Well, I'll show you on the board and you can
Yes.
decide. I think it'll fit.
I
I
don't know what we're
have an
talking about,
empty
but yes.
paper with holes in it. I'll just give it to you. If you run out of room on day 5 notes,
I want to draw like a little person for scale so that you
no, it's not that kind of tree.
make it
So you have to look like my tree. All right. I'm going to teach you how to do a probability tree.
A proper probability tree.
That's right. Very proper. So I'm going to leave this rule up
Sounds
here.
like
I'm
a tree,
going to
baby.
erase these. We
Sing your
won't
shirts.
need those today. I'll leave the mutually
Sounds like a tree,
exclusive
baby.
one up.
See your shirt.
I don't think we need independence anymore.
Where's our list of things?
And then do you have the list of things for senior shirts? For senior shirts?
I have the list of
saying
We'll
things.
start out with the simplest tree I
they're
could
just
think
all over my
of.
planner. It's not like a list.
No, we made a list.
Here's how it works.
Oh,
Flipping a
I've never had that.
coin, probability,
Flipping a coin.
flipping a fair coin and getting a tails the first time and the tails the second time. So we're going to flip it twice. And the way we would do that without the tree is to look at the sample space. The sample space is all the possibilities. So I could have gotten a head-head. I could have gotten a head-tail. I could have gotten a tail-head. Or I could have gotten a tail-tail. And there's no other combinations.
Tail-tail
When you're
sign.
flipping a coin twice, that is all. Is the board showing up, Elena, on here?
Yes.
Oh, good. All right, so we were wondering what's the probability of getting a tails-tails. There's only one way that happens. So the probability of getting a tails-tails is 1 out of how many possible ways?
4.
4. All right. So now I'm going to teach you that with the probability tree. I told you it would be a simple one, but then we'll advance. All right. So the probability of doing the tree is like this. So the first flip has occurred, and the possibilities are H or T. So now what is the probability that the first flip was a head? 1/2. What's the probability the first flip was a tail? 1/2. So notice the branch has the outcome at the end, and the probability is on the branch before it. So this is telling the
Can we
reader.
make it vertical?
Pardon?
Can we make it vertical so it's like an actual tree?
Vertical? They don't, so you can, but it won't be like ours. Alright, then the
I'm never the
second
same.
flip, if you got a head on the first one, the next one could be a head or a tail. Then if you had gotten a tail on the first flip, the second flip could be a head or a tail.
So we can do it vertical?
You can. You can. Mine are going to be horizontal.
Vertical.
I can only think horizontal. Alright, so what's the probability if you got a head on
So the
the
whole
first
vertical concept?
flip to get a head on the second one?
How big? How big?
How big
That's
is
it. That's
it?
So
Wait,
big.
why did you give us such a big paper?
My love for you.
I just said if you needed extra paper.
Oh.
So,
I don't need no extra paper.
so
My tree.
if you had gotten a tail on the first flip, what's the probability of getting a heads on the second flip? And so
Half.
on. So we probably wouldn't erect the whole tree just to do this one. But if we had, how would we find on it the probability of tail, tail? We would trace the branches, tail, tail. That would include 1/2 times 1/2. You always multiply along the branches. So we would have gotten 1/4 in a much harder way. But actually, I said for a simple example, the tree isn't worth the effort, but there are some problems. There's so many numbers and situations that the tree really helps keep them all separate.
Plus,
Thank you.
All right?
so
So
you
there's our
multiply
first probability tree.
You multiply all of the fractions?
You do. You multiply along the branches. So keep that separate from this. Because remember, this is saying what's the probability of getting a tail on the first flip and a tail on the second flip. So this is like an AND operation. So you're usually, I think you're always multiplying for AND. And notice over here, this is an OR operation. And we add it. So if you're doing this or that, add. If you're doing this and something else, then you want to multiply. I think that rule of thumb will hold true. Alright, so let me give you a chart. I think this was the same idea, but I think it has different numbers. So we're going to do the left-handed, right-handed, we'll do left-handed, right-handed, female, male, and we're going to do 3, 1, 18, 6. I'll put it in my totals as I go, so check them for me. Usually it's right if they both add up the same way. So once again, we have this situation looking at the relationship between left and right-handed, male and female. So, it's not as easy now without the tree. The tree really helps us when we have this. Alright, so let me build this tree, and then you'll build your own trees for me. Alright, before you can build the tree, you got to know what outcome you're looking for. So I was wondering, in this situation, if I pick 2 individuals, so 2 random selections, what's the probability of being left-handed on the first choice and left-handed on the second choice? Alright, so let's build our tree. So now that you know what we're looking for. So the first choice is either going to be a left-handed person or a right-handed person. So I'm going to put my branches in, then I'll go back and put in the probabilities. Suppose the first random selection was left. What are the choices for the next random selection? Left and right. So what if the first person had been right-handed? What's the selection choices after that? Left and right. Alright, now that looks very much like the head-tail tree we just had, but the probabilities are going to be way different. So, let's go ahead and see in the very first draw, what's the probability of getting a left-handed person? You got to get it from this chart. Brandon, can you find for me those numbers?
I'm getting a left-handed peasant?
Yes. How many left-handed persons are there? 4. And how many totals?
28.
Alright, so I'm going to write 4 over 28. I know it's reducible, but I'm going to keep it at 4 over 28. So if that is, what is the probability then of getting a right-handed person? We're going to grab the 24 over 28, or you could do the complement of that, whichever way you like to think of it. 4 over 28 and 24 over 28.
Do we, if the problem just asked for probability of left, do we have to like do all the values for?
You do not. Okay. Alright, so now, after we have selected one left-handed person, this is where it gets tricky. I'm going to change colors to emphasize, to draw your attention to it. Alright, I've already selected a person. They're sitting here at my table, they're left-handed. They no longer are in this group anymore. So what's the probability of getting the next left-handed person?
1 out of 9.
Because it's no longer 4 there. How many are there now? Alright, there are 3. Is the total 28 now? It is not, because I've already selected someone. It is 27. Alright, so 3 out of 27 is the number for the left-handed. Caleb, what would be, if the first person was left-handed, what would the numbers be for the right-handed person now?
For selecting a right-handed person after selecting
After selecting a left-handed.
it'd be 8 out of 9.
No, look at how many right-handed people there are. 20, there are. 24. Oh yeah, you
27.
reduced. Don't reduce.
24 out of 27.
24 out of 27, right. Do you see where those two numbers came from?
Why
24
is
out
it-
of 27. Pardon?
Why is it 27?
Because you already
when
picked one person.
We already picked a person who was
So it's out of the people that are
left-handed,
left.
so this number has gone down by 1. So now there's not 28 in the group, there's now 27. And the lefties, we picked the left-handed the first time, so 4 went down to 3. There's only 3 left. But there are still 24 right-handed people because the original choice was left-handed, but the total went down. See if you can get these two without me. So this branch, the first person chosen was right-handed. So now I want the possibilities of getting a lefty on the second choice. Alright, if I had chosen a right-handed person on the first choice, I still have the original number of left-handed people still there. There's still 4. Oh, let me finish these 2 fractions.
Okay.
Alright, so there's still 4, but the total number was 28, but we picked a right-handed person. That person is no longer in the pile, so it's only 27. However, if the first person was right, what's the chance of getting a second person that's right-handed? Well, there were, in the right-handed columns, there were 24, but the first one was chosen was right-handed, so this number goes down to 23, and the total is also 27. Alright, how did your branches turn out compared to that? Alright, so now, what's the probability of being a left-handed and a left-handed? So we're going to go down that branch, and what do we do with the 2 totals? Always multiply. If you multiply 4 over 28 times 3 over 27, you get 0.016, which is 1.6%. Alright, did you shut it down?
No.
Okay, now we need to. Whatever. Here we are.